Using an electronic moisture meter, like this one, is common practice in building surveys. They're used to assess moisture levels in materials like timber, plaster and masonry. While it's a handy tool, its effectiveness and accuracy depends heavily on how it's used and how the results are interpreted. I'm Paul Badham, Associate Director at Harrison Clarke Chartered Surveyors, and in this video we'll briefly explore its functionality, the benefits, limitations and what is best practice. Well, this protometer has many different functions, but this video focuses on the use of these prongs and the use of the back of the meter itself. It's a type of electrical resistance moisture meter. It works by measuring the electrical conductivity between the two pins or across the scanning plate. Moisture increases conductivity, so a higher reading suggests a higher moisture content. There are typically two modes. Pin mode uses two metal probes inserted into the material to measure resistance, and also scan mode, which uses a non-invasive sensor to detect moisture near the surface. These readings are displayed on a digital screen, often accompanied by coloured indicators: green for dry, yellow for at risk, and red for wet. There's also sometimes audible alerts. So firstly, they're quick and easy to use. They provide instant readings, making it ideal for rapid assessments, which then makes them useful for surveying large areas efficiently. Using the scan mode is a non-invasive approach and also allows for moisture detection without damaging the surfaces. This can be ideal for decorative finishes or historic buildings where minimal disruption is preferred. They're portable and lightweight, and their compact design makes it easy to carry and use in tight spaces. They're usually battery powered and durable for fieldwork. They can be used on timber, plaster, drywall and masonry, and this helps identify potential damp issues before they become serious. They're also effective for comparing moisture levels across different areas. This can help isolate damp zones for further investigation. However, there are some limitations. Firstly, they do not measure moisture directly. The protometer does not measure actual moisture content. It measures electrical resistance, which can be influenced by salts, chemicals or other materials. For accurate moisture content, galvanometric or carbide tests might be needed. They can also be prone to false positives. Materials like lime plaster or treated timber can give high readings due to salts or preservatives, not moisture itself. This can lead to misdiagnosis and often can be used for unnecessary damp-proofing treatments. They also have a limited accuracy in masonry. Electrical resistance meters are unreliable in masonry, especially if it's been painted, treated, or it can contain salts. Readings can vary widely depending on wall composition and the surface condition. Some surveyors rely too heavily on damp meters without considering the context or conducting further tests. This might lead to mis-selling of damp treatments, costing homeowners millions annually. The use of a moisture meter requires skill and interpretation. Not all surveyors are trained to correctly interpret the readings. A high reading doesn't always mean a damp problem. It could be environmental or material related. Best practices for using a meter would be to combine it with a visual inspection. You should always pair meter readings with a thorough visual inspections, looking for signs such as staining, peeling paint or mold growth. It can be used as a screening tool. So it should be treated as a first-line indicator, not a diagnostic device. It can be used to identify areas that may need further investigation. Sometimes it may need following up with scientific testing. For definitive moisture content, a galvanometric analysis or carbide testing will give a more accurate result. These methods might involve sampling and sometimes lab analysis for precise results. You should also be cautious of using a moisture meter in historic buildings. They often contain lime-based materials or historic finishes that can skew readings. Always avoid recommending investive treatments based solely on meter data alone. It's important to explain the limitations of the meter readings to homeowners or clients. This can be used to prevent panic or unnecessary spending on misunderstood readings. In conclusion, the damp meter is a valuable tool when it's used correctly. It offers speed, convenience, versatility, making it a staple in many surveyors' toolkits. However, its readings are not definitive and must be interpreted with care. Misuse can lead to costly errors, especially in older or complex buildings. The key is to treat the meter as a screening device, not a complete diagnostic solution. When it's combined with experience, visual inspection and scientific testing, it can be a powerful ally in measuring moisture-related issues. If you're considering using a moisture meter or interpreting the readings of a survey, make sure you know the context and not just the numbers. As always, if you need help or advice with this or any of our other topics, please feel free to get in touch via our website, harrisonclarke.co.uk, and I'll see you in our next video.